For decades, the story of Alzheimer's has been told like a detective novel with two main culprits: amyloid plaques and tau tangles. These sticky protein clumps were the villains everyone blamed for the brain's decline. Billions of dollars in research and countless experimental drugs have been aimed at breaking down or blocking these structures, but the results have been, at best, underwhelming. Now, researchers at Purdue University are suggesting something refreshingly bold. Maybe we've been chasing the wrong suspect all along. Maybe Alzheimer's isn't just a plaque problem. Maybe it's a fat problem hiding in plain sight. Here's where things get interesting. Inside the brain, the immune system has its own tiny guardians called microglia. These cells act like vacuum cleaners, sweeping up debris, gobbling misfolded proteins, and keeping the neural environment tidy. But the new research shows that when microglia are exposed to amyloid plaques, they don't just get distracted, they get stuffed. They start hoarding fat droplets inside themselves until they can barely move, like someone who meant to tidy the house but ended up buried in their own clutter. Instead of continuing their cleanup duties, they slump into dysfunction, leaving the brain more vulnerable to chaos. The culprit behind this fatty overload is a sneaky enzyme called DGAT2, which refuses to break down when it should. Instead, it hangs around converting fatty acids into long-term fat storage, even when the microglia would be better off burning those fats for energy. In other words, the brain's cleanup crew is being sabotaged by its own metabolism, not just overwhelmed by plaques. And when you zoom out, this flips the whole Alzheimer's narrative. It's not that plaques are irrelevant. It's that they might be setting off a chain reaction that leads to fat hoarding, and it's the fat that cripples the brain's defenses. Now, here comes the hopeful twist. If the problem is fat mismanagement rather than unstoppable plaques, then the solution may be more attainable than we thought. In mouse models, when scientists targeted DGAT2, either by shutting down its activity or encouraging its breakdown, the microglia slimmed down, perked up, and got back to work. They started clearing amyloid again, restoring balance in the brain's ecosystem. It's like giving the exhausted janitors a lighter workload and a better mop. They immediately become effective again. What makes this discovery so powerful is that it's not just about Alzheimer's. It's about reframing neurodegeneration itself. For too long, we've thought of the brain as being crushed by immovable, sticky structures. But this new perspective suggests the brain might be more flexible than that, more metabolic, more dynamic, and therefore more open to intervention. Fat buildup can be altered, enzyme activity can be tweaked, and immune cells can be restored. That doesn't mean the fight is easy, but it means it's winnable in ways people didn't dare to hope before. There's also something deeply reassuring about the shift in focus. Plaques and tangles always felt like inevitable death sentences, ancient scars that couldn't be healed. Fat metabolism, on the other hand, is familiar territory. It connects Alzheimer's to a broader web of health issues like obesity, inflammation, and aging, all areas where science has already made major progress. If the brain is struggling with a fat problem, that means there are levers we can pull, diets we can explore, drugs we can design, and maybe even lifestyle interventions that could keep microglia nimble and functional for longer. This doesn't erase the role of plaques, but it does take away some of their terrifying mystery. Instead of faceless monsters, they become triggers in a chain of events we now understand better. And with understanding comes control. Alzheimer's starts to look less like an inevitable curse of aging and more like a puzzle that's finally being pieced together. So maybe the story of Alzheimer's is shifting from one of hopeless plaque fighting to one of fat management and cellular balance. And if that's the case, then decades of stalled treatments may finally give way to real progress. After all, we've been treating the brain like it's under siege by stone walls when maybe it's just weighed down by clutter. And clutter, unlike concrete, can be cleared away.